Okay, so 2.8, there's a couple things in 2.8. Okay, but we're just going to focus on what's called linear approximation. And it's kind of interesting because most times in math we don't approximate, but this was something that they felt was useful. You have to remember, back in the 17th century, there was no calculators. So estimating to them probably had even more value back then, even though we didn't always like to do it. It actually, you know, they couldn't just go to their calculator and type it in. Okay. And like I said, I think yesterday, it circles back to a topic we've been doing. So I think it'll kind of be a nice little summary to end the chapter. Tomorrow, Wednesday and Thursday review, test Friday. All right, so I'm going to use this in just a minute. So let's do section, let's at least get this in, section 2.8, linear approximation. Linear, kind of like polynomials, the very basic equation to use. And so anytime you can substitute a line into any other equation, makes it easier. Right? Does that make sense? We're going to take stuff and just take it down to a line. Okay, let's see. Let's see if I can do this. I'm going to new share, and I'm going to share this guy. Okay, so what is this a picture of? See, that's about as big as it can get. Does anyone know what that is a picture of? We've got an equation, an f function, and then what's the red line? The red line is the tangent, right? And what have we been doing with derivatives? We've been finding the slope of the tangent. Okay? All right, so where does this linear come in? What they say, or what they noticed is, look at this little box. From, let's say from here to here, can you tell much difference between the blue, the parabola, and the red, the actual line? Can you see how they're so close? Even like when I drew it here, let's even just put it up here. Do you see how they only share, the parabola and the red line only share this one point? That's it. But how close around it? Like if I go from here to here, do we see how they're very, very close to each other? Okay. And so instead of using the equation of the parabola, they said, hey, let's just use the equation of the line. They're so close anyways. As long as we're around this point, which remember this was the A value. As long as you're around the A value, you can use the line instead of the parabola, or remember, it can be much, much different than a parabola, right? It could be trig, it could be a square root, okay? So if you don't want to use the given f function, I think we can take this off. If you don't want to use the given f function, and I'll have one more example if we'll have to see visually, to see it visually. All right, so if you don't want to use, for whatever reason, now this is a parabola, so this might not be too bad, but if the f function is crazy, all right, and let's say A was 3. If you need something at, let's say, 2.9, you could definitely use the tangent line instead. Would it be exact? No. Would it be close? Yes. Okay, and that's why it's called approximation. Does that make sense? So, for now, we'll come back to it maybe one more time. All right, so let's take a look at some. Oh, I know what we're going to say. So if we're going to maybe use this red line instead, we're back to writing. Let's write this. This is the tangent line. And the tangent line, we're also just kind of rename it. We're going to name it linear approximation, or they like this word. Well, we could put that also is linear approximation. so we've been calling it the tangent line, and that's what it is, and it is technically only tangent at that one point. But now we're just going to use it to estimate stuff around it. Hence linear, because it's a line, right? And then we're going to use it to approximate. It's kind of just the directions have changed. And then we'll go on and use it in a few places, okay? But the first two examples are just change of directions. Okay, we're just recalling it. And then we'll go on and kind of use it a little bit. All right, so let's put up here. Well, I'll put the directions maybe up here and then we'll start fresh over there. But that way you can get everything copied down. They say find the linearization. They like that word. Spell it right, linearization. And then they call it L, capital L of X. Of the given function. Of the given function at point A. For us, as far as the procedure, and it is also the same thing, for us, what we've been doing is finding the tangent line. Okay? So this same thing, this linearization L, is really just finding the tangent line. It's the same line. We either usually just focus in on its slope, or now we're going to use it to approximate around A. So it just has more, it has more meaning now. All right, we're adding another thing we can do with this line. Does that make sense? Maybe that's the best way to say it. We're now just adding literally one more thing that we can do with this tangent line. We spent all chapter on it, we might as well do some things with it, right? Okay, so let's look at our function. And I kept it just as a parabola. I think on the homework it does go x to the fourth, but that's okay. F of x equals 5x squared plus 4x. And we're doing stuff when A is -2. All right, so whether it's a tangent line or linearization, something we're going to use to approximate some stuff, same line, and it all goes back to y minus y1 equals mx minus x1. So what do we have? We need three things. We need the x, we need the y, and we need the x. It kind of goes in that order. We have the x. What is x? X is -2. Okay, so we had that all along. They have to give us something. All right, so x is -2. How would I find y? Y is on the parabola. So y is this guy. Don't even take the derivative yet. Y is going to be f of, and we'll go ahead and plug in the -2. So 5 -2 squared plus 4 times -2. So the first thing you want to do is just find y right on the function. All right, and then just go through that. What does that give us? So that'll be y. I might drop this out because I now want to think of it in terms of specifically y. And you can type it into your calculator if you want. Just be careful here. If you do it, this is +4, and this is actually -8. 20 minus 8 takes us to 12. Okay, so we got another piece. We got -2, and now we've got 12. Blue, but that's okay. All right, what else do we need? The last piece is slope. How do we find slope? Derivative, right? Those were going together. So for m, I need to take the derivative. For m, I need to take the derivative. So for y, just literally plug it in. You can use your calculator if you want. For slope, you do have to find the derivative, right? So we go back to the original, roll it down, subtract 1. So that gives us 10, right? Because we roll it down, we multiply x to the first. And then 4x goes to 4. Right? And where do we want slope? We want slope at -2. -2. So remember, first we plug the -2 in just to get y, and then we're going to plug in the -2 into the derivative to find slope. 20 plus 4 takes us what, to -6. Okay, and then, okay, then we just plug it in, right? We could just plug it out, just rewrite this up top. So, y minus y1 equals m, x minus x1. Plug in what we know. Y minus and y1 we found out to be 12. Our slope, the derivative gave us -16. And then x, now just be careful here, it would be minus a -2. Do we see that? Is there minus in the formula? And then x just happens to be negative. If you go right to plus, that's fine. Okay, in your notes, if you want to put the double negative, just to remind yourself. All right, let's rewrite it. +2. And then distribute. And that answer's okay. I think on the homework they make you solve for y. But remember, in general, that's okay. Y minus 12 equals -16x. It's maybe good to remember you distribute to both, so -32. And then add 12. -16x minus 12. All right. What is that? That is the tangent line on this graph at -2. And, so this is the tangent line. And we can also use it as a linear approximation. As long as I am around -2. It's obviously not going to work if in order to use the approximation, I have to be around my original A value. Okay? So this tangent line we've been doing for a while now, we're just adding another component. It could also be a linear approximation around -2. All right, let's try one more of these things. For these guys, I'm going to do a new share of this. You guys. Use this technology if we have it, right? Okay, so what is this a picture of? Let me see. There it is. Okay. So the blue is the parabola, okay, and the red is the tangent line, or now our linear approximation. Okay. And I just typed those in. We go to y equals, I just typed it in ahead of time because it takes me forever. So there they are. And then I just wanted to show you, let's go back to graph. Okay. So I'm going to hit trace, and I'm going to type in, like, let's do -2.01. Do you see how I have to be close to my A, which is -2? Okay. All right, and I'm on the blue, so I'm on the parabola. So for the parabola, that's the exact value. That's the exact value because I am on the parabola. Okay. So at negative, we're going to write this down, but what did I put in -2.01? The exact value was at the bottom there, 12.1605. But if I thought for some reason it would be easier just to use the line, so let me go to the line, go up. So now I'm on red. Do you see how that's red? And I do I have to trace -2.01? What does the approximation give me? 12.16. So I'm in the ballpark, right? This was the exact. and the red line gave me 12.17. Do we see how they're so close? This is a great picture, right? I mean, we could look for a while. It looks like the red and the blue are actually pretty close together. So this one, we could maybe even go a little bit further up. Let's see, let's do this. Let's do negative 2.1. Should we do 2.2? Let's do 2.2. Let's see. That's 15. Let's see what it is on the blue. Negative 2.2. Not too bad, right? It was 15.4 and 15.2. So we're starting to kind of get away. I mean, there's sometimes if you're pretty close to that A value, if you're pretty close to negative 2, look how close it is. But here it would still round to the whole number of 15. Okay? But we're pretty far away. By the time we did 0.2, we're talking usually about 0.1 is the most that you can use. But do we understand? Yes, that you can use the red line. And again, it all depends on how hard this equation is. You know, this one gets harder and harder. A nice line looks easier and easier, okay, especially when you don't have a calculator. Okay, good. All right, let's try another one. And this one might be a little bit harder. Let's see, let's go back to share. All right, done with all our fun stuff. Okay. All right, let's try. Same directions. Turn that off. Let's make one a little bit harder. F of x equals x to the 1/3, and our A value is 8. Directions say something about that. Find the linearization. But for us, what is that? And not really for us. It is the same thing as the tangent line that we've been finding. All right, so we want to fill in y minus y1 equals mx minus x1. We've got x, right? X is 8. All right, so now we got to go find y. You might as well, since for y we use this, I usually go find y first. You can always find it later if you forget. But just remember that y just uses your regular original function. We want the y value on that original function. Okay, now it's okay if you use your calculator, but does anyone know 8 to the 1/3? What's that 1/3 power the same as? This is the same as the cube root of 8. Remember that 3, technically that exponent of 1 goes here. We'll use that a little bit later, but an exponent of 1 we don't care about. So cube root of 8, what do you multiply 3 times and get 8? 2, right? 2 times 2 times 2 gives you 8. So this guy, which is y is 2. And again, if you have to use your calculator, if that helps, that's okay. Okay, so we got x, we got y, we need slope. How do we find slope? Derivative, all right? So let's take a look. How are we going to do the derivative of that? I'm just going to rewrite it here. How do we find, let's put m, so we remind ourselves. Roll it down, so the 1/3 just simply rolls down. And then we're going to subtract 1. X to the 1/3 minus 1 is negative 2/3. And again, if you need your calculator, that's okay. We could do some things here. Because this is negative, the 3 is already on the bottom. And I could put this on the bottom as well. Slide that piece down because it has a negative exponent. You could save it for later. There's different ways to do this. I usually just make a positive right away. I can also look at this as the cube root of x, and then square it. And usually we put the 2 on the inside, but it's actually, if you have to actually do the work, it's easier to put the 2 after. Negative, we slid it to the bottom. That's the 3 on the bottom. That's the 2 on the top. Because now what am I going to do with that? What am I going to plug in for x? This, we probably would have stopped here. This is our derivative. But if we're going to go use it, we want to go plug in 8. So now to actually find m, 3, and I'm going to take the cube root of 8 and then square it. How are we doing? Should we slow down? Are we okay here? At least taking the time to rearrange it? And again, if you use your calculator, that is okay. All right, so what do we get here? 1 over 3 is going to stay. The cube root of 8 is still 2, and then we just have to make sure we square it. Okay? So 2 squared takes us to 4. So 1. Oh, let's go here. So we got this guy, and then we got these guys. I think we can erase everything else. We'll start over here. Almost done. We got y minus y1 equals m x minus x1. Okay. Y minus y, which is a 2, m, which was the 1/12, and then x minus x1, which is and again, that answer isn't bad. I think that left side makes us solve for y. So that would give us, we could distribute here, so that would be 1/12 x, and this would be 8 over 12. And that reduces down what 4 goes into both. And again, calculator more than fine. 2/3. And then, or if you don't reduce, that's what you do. Add 2 over here, because I don't have a calculator, I'm going to write this as, instead of 2, I'm going to write it as 6/3, because I'm getting a common denominator. Okay, again, if you just want to do negative 2/3 plus 2 on the calculator, that's fine. All right, and y equals 1/12 x. That should be 4/3. Okay, so what is this? This is tangent line, or we can now use it as a linear approximation. Our original was x to the 1/3. So for some reason, if I don't want to do cube roots, or I don't have a calculator, even though there are fractions, this would still probably be a little bit easier. But what number do I have to be around? X cannot be like 20. X would have to be very close to 8. If I want to use this instead of x to the 1/3, I gotta pick numbers around 8. Okay, so let's do 1 or 2 problems where we actually have to use it. Because otherwise, we've kind of been doing this. It's just literally changing the name. All right, so let's do this. Get a fresh board. Example 3 is actually a little bit longer than 4. But 4, there's one tricky part. So if we make it through 3, 4 will be easy. All right, well, let me write up the directions and then I'll erase that half. Find the linear approximation of, and then they give us the function, the square root of 9 minus x at a equals 0. That's kind of nice. Then use it to approximate That makes sense that it's in the directions. The whole goal is to use it to approximate something. So here we go. Now we are actually going to use that line then to approximate the square root of 8.9. And then they give us 2. And the square root of 8.9. So we found slope for the tangent line. Now we're going to find the tangent line to use it as an approximation and then actually go approximate. Kind of like, you know, there was an old lady who swallowed a, yeah, right? So now, right, we did the derivative to write the tangent. Now we're going to do the tangent to use it to approximate. Okay, so the first thing we have to do is write the tangent line. Remember, the linear approximation is the same thing as the tangent line. So we have x. What is x? X is 0. Then the next thing we're going to go do is find y. Y is going to be f of 0. So the square root of 9 minus 0. Go back to a regular f of x. And that's actually not too bad, right? That is 3. And then the last thing we need is slope. To find slope, we have to find the derivative. We might want to back up though, because before we find the derivative, what are we going to do with our equation? Let's rewrite it. Maybe we can just do it over here. You can hold on to that. Because how do I want to write f of x if I'm going to have to take the derivative? What do you think? Go ahead. What do you think? All right, we got to do 9 minus x. And instead of a square root, we've got to, in order to do derivatives, you need exponents. All right, so let's write it to the 1/2. Remember, the square root is the same thing as an exponent of 1/2. Now we can officially take the derivative. So now we can go and do the derivative. All right, so what is that going to look like? We have to, now this one's kind of tricky. I told you our authors, these are tricky. All right, we got to roll this down. Subtract 1. So 1/2 minus 1 takes us to negative 1/2. That wasn't too bad. Why is he tricky? We just did that derivative on a quantity. This guy is q. So now we have to take it times the derivative of the quantity. That is our q, that's a quantity. Remember, all quantities are in parentheses. So if you roll it down and subtract 1 in parentheses, you've got to take it times the derivative of the parentheses. Okay, so that doesn't seem too bad. The derivative of 9 goes to 0. But what about this guy? What's the derivative of negative x? Negative 1. So it's like that on your homework too. Make sure that you don't miss that negative 1. All right, so maybe we could clean it up a little because we do have a negative exponent. However you want, now we have to plug in 0. If we want to clean it up first, we could, the negative 1 could be on top, 2 is on the bottom. I could move this to the bottom and put it back in a square root. However you want. If you just want to go right to your calculator, that's fine. The negative is going to stay on top. How come this negative doesn't slide to the bottom? I thought negatives mean you slide it to the bottom. It has to be a negative exponent. All right, so this negative 1 staying right where it's at. 2 is on the bottom to begin with. This negative exponent slides to the bottom. 1/2 then takes it to the square root. All right, and then we plug in, you know what we plug in? We plug in 0, right? Because that's where we want the slope. Everything started with an a value, or remember it's an x value of 0. So -1 over 2 square root of 9 minus 0, which is really just the square root of 9. It's 3. So -1 over 2 times 3, so -1. And that is our slope. That's our path. Okay, so let's rewrite. I think we can rewrite. Oh, let's see, I might need this, right? So this 0, give us 0, 3, and then a slope of -1/6. All right, so now we go y minus y1 equals mx minus x. All right, so y minus 3, slope was negative, or here, -1/6, x minus, and now it's negative. So we don't need the -0, because subtracting 0 doesn't change anything, so we really just have -1/6 x. So if we don't have the -0, then we don't really need the parentheses. If you want to think of it as distributing, you can, because -1/6 times 0 is still 0. And then add 3. Okay, so we're getting pretty good at this. Remember, we found slope for the tangent line. We wrote the equation of the tangent line. Usually we were done with that. We kind of looked, oh yeah, we could graph it and see that it's tangent. Now can we use that to approximate the square root of 8.9? So let's look at that part. So this is the tangent line. This is also the line, linear approximation. Okay, sometimes they call it linearization. Okay, so let's look at our function. Our function is square root of 9 minus x. What would x have to be to get an answer of the square root of 8.9? What would our x have to be to get an answer of 8.9? What would we have to subtract from 9 to get 8.9? 0.1, yeah. Now, if you're not sure, you could say, okay, 9 minus x would equal 8.9 and actually go through it. But some of you should be able to kind of look at that. But if not, then you would just set the two equal to each other. If you subtract 9, you get negative x equals negative 0.1, and then divide by the negative. But it's definitely okay just to kind of look at it. If you want to do that as a check, you could. So now we're going to take 0.1 and plug it into here. So we're going to do y equals -1/6 times 0.1. And that is the approximation of the square root of 8.9. This is going to be approximation. That is going to give us the approximation of the square root of 8.9. Now it's up to you. Well, you got three choices. One, you could use a calculator. All right, and I'm okay with that. But two, the question is, could we approximate this without even using a calculator? All right. There's two ways. You could either change this to a fraction or change this to a decimal. The only thing is, does anyone know what 1 divided by 6 is? So you might use your calculator for that. Some of these are easier where we would know it maybe. Years ago, they probably had some charts, okay? Because some of these probably came up quite a bit. I'm going to try. It is, did anyone type it in? It is negative. It is repeating. I think it is 0.16 repeating. So we'll do 1.67. Did I check it? Did you check it or no? 1 divided by 6, 0.16. Okay. So times 0.1 plus 3. All right, but this isn't too bad. What happens when you multiply by 0.1? It moves the decimal over one place. So negative 0.0167. And then plus 3. And again, you could type that into your calculator. That's doable, though. We could, I don't know, some of you might be able to do that in your head. But otherwise, and again, if you use your calculator, that's okay, but it's kind of cool to see how far you can get without literally using a calculator. This would go to 2, 10, but then 9, 10, but then 9, 10, but then 9, 10. So 3, 3, 8, 9, 1. Okay, so let's use our calculator. What is this number? This is what we use from our linear approximation for the square root of 8.9. What is the square root of 8.9? 8.9 is the official answer, 2.9832867. So how do we do for approximating? Not too bad, right? Especially, and again, remember, without calculators, right? I mean, that's kind of what they were using this for, okay? Ways that, I mean, they still had to do arithmetic, absolutely, but not too bad. Kind of cool. All right, considering they were in the 17th century, pretty impressive. All right, so let's do the same thing. It's pretty much the same thing, but let's do it for 8.99. So now the thing you have to realize is if I'm approximating the square root of 8.99, remember, where do you start? You have to say, okay, what would my x have to be to go from here to 8.99? What would your x have to be? Beautiful, 0.01. Perfect, yeah. And again, if you don't know, you could set it equal. That would be okay, don't panic if you actually can't figure it out or you just want to make sure. But yeah, it should be 0.01. Or you could check it, right? You could do 9 minus 0.01 and you should get 8.99. So remember, you have to figure out kind of like, okay, what should x be so that I get that number under the radical? Right? Then it's just a matter of I erase it, right? But then we're going to use it in the linear approximation. You can see here negative 1/6. This time it'll be 0.01. And then this one we might have had to use the calculator. What do we say? 0.167. What does multiplying by 0.01 moves it 2 places to the left? So now we've got negative 0.00167 and then plus 3. And again, you could use your calculator there. Otherwise, we could do a quick stack. I think it just adds another 9, right? 2.99. Positive, right? 2.99833. And then again, we could check it on the calculator as well. Let's see, because we're even closer, it should be even closer. Because we're closer to 0, it should be even closer to the right answer. Square root, but obviously 8.99 is pretty close to the square root of 9, which is 3, right? Let's see, 8.99. I got 99833. It actually matches perfectly. There's just a little bit more after it, right? Because it is irrational, so it actually goes on forever. But up until 1, 2, 3, 4, 5 places, that's the square root of 8.9. Which I know you all were dying to know what it was anyways, right? Okay. All right, let's try. So remember, this problem, you have to come up with the x on your own. Okay, try to remember, you correlate. What would x be to give me this number underneath? Okay, that's what you have to remember from these slides. All right, let's do one more. All right, use linear approximation to estimate (2.99 to the 4th power). Okay, so this you have to come up with even more stuff on our own. We have to create a function on our own. This is what got kids last year, but we're going to try to keep it as basic as we can. So f of x, what is 2.99 really close to? 3. So we're going to write this as 3, and then plus, we just have to adjust it by putting in a value. If we just adjust it to putting in a value, then we can come up with 2.99. Okay? But what we're kind of doing here is we're kind of using 3 instead of 2.99. Okay? And don't forget to the 4th power. Now, what would x have to be so that we do have 2.99? X would have to be negative. I kind of like using the plus, and I'll show you why in just a minute, and just making your x negative. So x would have to be negative 0.01. But we don't really want to use that. So what would a good a value be? What is this x pretty close to? Because remember, whatever we use, our a has to be pretty close to that. But it sets us up beautifully. What would be a great number? 0. Okay. So all of that you have to come up on your own. I'm going to throw it one more time. We said 2.99 is pretty close to 3, and then we can just adjust it with a little value. Okay. We figured out that value would be this guy, which means that we can make an a value of 0. Because we're just trying to pick numbers that are easier to work with. Okay, now we're good to go. So now, not only do we have this, but this is our x value as well. We're going to kind of now put this off to the side, and we're going to plug in the 0. Let's go find y. Now we're using this equation that we wrote on our own. 3 plus 0 to the 4th. 3 to the 4th. 3 to the 4th gives us 81. So now we're literally writing the linear approximation. So we've got x, we've got y, and then we need slope. So let me just rewrite this. 3 plus x to the 4th. Let's go find slope, which is the derivative. Roll it down. Subtract 1. I did it on a quantity. This is why I like the plus so much better. I did it on a quantity, but what's the derivative of that quantity? This guy goes to 0, and then plus the derivative of x is 1. So I didn't forget about it, but the derivative is actually 0 plus 1, which is 1, and we're multiplying, so we don't even care about it. If it's minus, then that changes some things. So anytime I can write it, I just always like to use a plus. So in case I forget, no one will know. I never forget. All right. Okay, so we can just use this guy. So now slope, we're going to plug in. Do we know what we're going to plug in? We're going to plug in 0. Right. Once we find that a, we're going to use that throughout the whole thing. 3 plus 0 to the third. So that just gives us 3 to the third. 4 times 27, 108. Okay, let's, I'm not gonna hang on to it. Let me just put it right here. Because we might need some of this. We might need this again, right? So we're gonna do y minus y1, which is 81, equals slope, which is 108, and then x minus 0. Okay. So we don't really need the minus 0. Equals 108x. And then we can add 81. And so we've got y equals 108x plus 81. Okay, what are we going to do with that? We kind of have already answered this question. Remember, we were working on this. What would x have to be to get us 2.99? That negative 0.01. So we're going to plug that. Let's plug that in. Y equals 108 negative 0.01 plus 81. I changed this equation to this line as long as I'm around 0, and sure enough, I am around 0. All right, so what does this do? This just moves the decimal 2 places to the left, and then the negative, so negative 1.08 plus 81. And again, you could use your calculator. If you take off 1, you're down to 80. And then if you take off 0.08, that would take us down then to 79.92. Okay, so now let's check it. Let's do what is 2.99 to the fourth. 2.99 to the caret 4 is 79.925388. Now, this is the exact value. This was our approximation from our line. And that's kind of the cool thing. Like, once you have this line, then you just use that. Notice I didn't do anything to the fourth power, right? I literally used that line instead of this equation, which would have given us that 2.992. All right, so homework is 2, where you just have to write the equation on the line, whether you consider it a tangent or a linear approximation. And then the other 2, see if you can try to use it. Okay. All right, and then Wednesday, we got another review sheet. Thursday will be the same thing. You guys are all invited back Thursday. If you want, we'll talk about more of that on Wednesday. I think I'm also going to give you the problems worked out. Okay, it's not a save all, but it might help some people. And then test on Friday. Stop.